Hello. In this video, we will use properties associated with trigonometric functions to evaluate those angle measures that are not found in a unit circle. First off, we need to be aware of two formal definitions. The first of which describes the angles used in a unit circle when evaluating trig functions. Angles are said to be in standard form if we measure them by placing the initial side of the angle on the positive x-axis of a unit circle and rotating counterclockwise to locate the terminal side. All angle measures between 0 and 360 degrees, or between 0 and 2 pi radians, are identified this way in earlier lessons. Since some angle measures will not exist inside a unit circle, we must use coterminal angles to evaluate them. Coterminal angles are angles in standard position that have a common terminal side. It is easy to visualize coterminal angles if you imagine the terminal side of an angle is like the hand of a clock spinning around the face until it lands in the same position as before. For example, we could increase the 45-degree angle by 360 degrees, and the new angle, 405 degrees, is in the exact same position. We could also decrease the angle by 360 degrees and see that an angle measure of negative 315 degrees is found in the same position. Since terminal sides of these angles are found in the same position, the trigonometric functions evaluated at each will be the same. For angles measured in radians, we accomplish the same goal by adding or subtracting 2 pi from each angle measure. Try finding a positive and negative coterminal angle for the remaining examples on your own now. Resume playback in a moment to check your work. It is important to find common denominators when finding coterminal angles of those measured in radians. Not only does the use of coterminal angles prove to be useful, so does the use of trigonometric identities, or properties. Using these properties will allow you to consider different ways to represent provided angle measures if they are not found in the unit circle, so that you can more easily evaluate them. The first group of identities, or properties, is called the quotient identities. These show that tangent of an angle measure and another trig function called cotangent can be described as the quotient of sine and cosine functions evaluated at the same angle measure. The reciprocal identities define trig functions that might be new to you. The cosecant function is the reciprocal of sine, whereas secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Should you need to evaluate one of these functions at an angle measure, you would evaluate it using the reciprocal function and reciprocate, or flip over the fraction. Finally, the even-odd identities give us the ability to change the signs of trig functions without necessarily finding coterminal angles. The sine function, as well as cosecant, are odd functions. So when evaluated at the opposite of an angle measure, the result will be the opposite of the function evaluated at the original angle measure. Tangent and cotangent are also odd functions and behave the same way. Cosine and secant are even functions. So when evaluating these at the opposite of an angle measure, the result would be the same as evaluating the functions at the original angle measure. Let's take a look at a few examples to better illustrate these properties. In example 1, we are asked to evaluate cosecant at 2 pi over 3. Since cosecant is the reciprocal of sine, I would evaluate the sine function at 2 pi over 3, then flip the fraction. It is worth noting that we will usually rationalize the denominator if a radical appears in the denominator. In example 2, we must evaluate cotangent, which is the reciprocal of tangent. But we must do so at an angle outside of the unit circle. So we must reduce this one by 360 degrees repeatedly until we arrive at an angle measure inside the unit circle. We see that after two reductions, the position of the terminal side of 945 degrees is the same as 225 degrees. Tangent of 225 degrees is equal to 1, and the reciprocal of 1 is 1 as well. In the third example, we must evaluate cosine at negative pi divided by 2. And because of the even-odd identity for cosine, we would obtain the same result by evaluating cosine at a positive pi divided by 2. I would like for you to pause the video now and resume playback in a moment to check your work. Be sure to consult each of the identities above and utilize them to evaluate these functions using sine, cosine, or tangent with angles found in the unit circle. No calculators would be necessary if you memorized the positions within the unit circle. Good luck.